Hello students, welcome once again, and we have a Taylor series over here. So give the Taylor series of the function. So we have to give the Taylor series of the function f of s equal to the ln of 3 plus 4x at s equal to 0. Now in general, the Taylor series is given by, we have f of s equal to the summation, this goes to infinity, n equal to 0, and we have f exponent a, then we have a here, then x minus a, right, over n factorial is equal to, so we start from when n is 0. So when n is 0, then we can have f of a here, then to the power 0, then we can write out the rest of them. So when n is 1, then we have this x minus a, then we have divided by so if this is n factorial, then for n equal to 0, then we have 0 factorial, we have 1 factorial here, then it continues for the rest. So when it is 2, then we have s minus a, remember it is to the power 1, this is to the power squared, then we have 2 factorial, and it goes on and on. So this is what we have. Now before we are able, so we have f of s being equal to the ln of 3x plus 4 as that. Okay, so we have to find the Taylor series for that. Now we are going to start from when f is 0, then we start from f is 1, then it goes on and on. So when f of s is equal to the ln of 3x plus 4, that is when x is equal to, now in general, s is equal to a for the Taylor series. So when s is equal to 0, then a is equal to 0. So take note of this, we are going to use that. So we have over here, we have f of s being equal to the ln of 3s plus 4. Then at that, if you have this, then this is what we have for f of s equal to that. Then the next thing is that we are going to differentiate, because in general the series is when for the second one here, we differentiate first differential, we give it the second differential, then it continues the third differential, the fourth differential. So we are going to differentiate f of s with respect to that. So in differentiating this, we have the ln of 3s plus 1 is basically you getting 1 divided by the 3s plus 4. Then after that, we differentiate what is here. So differentiating what it is, f of 4x, not 3x, so it's 3 plus 4x. So differentiating this, we have multiplied by 4, which is just 4 divided by that. So this is just equal to 4, then we bring all of this to the top there, then we have 3x plus 4, then negative 1 here, right? Okay, so let's move on to the next one. Now we do the second differential. So we are differentiating this. So in differentiating this, what will happen is that we drop the negative 1. So we have negative 4, then 3x plus 4, then we subtract 1 from it, which is negative 2, right? Then we differentiate what is here. So differentiating, it is still 3 plus 4x. So differentiate what is here, we have multiplied by 4. So this will look like we have 4 multiplied by 4, so it says minus 4 to the power square, then we have 3x plus 4, then minus 2. I want to leave it in this form, because we are going to write the general Taylor series in this form. So we have so we do the third differential. So in the third differential, we just drop the negative 2 here. So when we drop it, become negative, then becomes positive. So we have we still have 4 squared, so it become positive. Then also we drop the negative 2, so multiplied by 2, right? Then we have 3. Why do I keep writing? Is 4x, so it is just 3 plus 4x. Then we have negative 3, because we subtract 1 from it. Then we differentiate what is here, which is just 4. So it will look like 4 multiplied by 4. So go 4 cube. Then also 3. Remember that we squared here, so we have 2 here. So we have 2. Then 3 plus 4x. Then minus 3. We do the fourth differential. Then we have also, so we have negative 3 multiplying 4 to the power cube. So we have 4 to the power cube. Remember it's negative, so we have negative over here. Then we have 2 already there. Then the 3 here. Then we write the whole of that plus 4, 3 plus 4x. Then minus 4 here. Then also we differentiate what is there, so 4. Then all of this will look like negative 4 cube multiplied by 2. Then we have 3. Then 3 plus 4x. Then to the power negative 4. Then we do the fifth differential. So we can continue and on, but I'll stop here. So the fifth differential, it will just look like, so negative 4 drops. So when negative 4 drops, we have 4 cube. So it becomes now this was 4 cube and there was 4 multiplying, so this becomes 4 here multiplied by 4 cube. So it becomes 4 to the power 4. Sorry. So over here it will look like, so negative 4 drops, then becomes positive to the power 5, then multiplied by 2, multiplied by 3, multiplied by 4. So then also we have 3 plus 4x, then to the power negative 5. So these are the series look like. Now look at the trend over here. Now realize that for the first part I have this. Now for the second part I have positive, I have negative, positive, negative, and positive. So there is positive, alternating positive, negative throughout the series. And also I have 4 to the power 1, 4 to the power square, 4 cube, 4 to the power 4, and also 4 to the power 5. So there's another trend. Then also 3 plus 4x, 3 plus 4s, then all to the power negative 1, 3 plus 4s to the power negative 2, negative 3, negative 4, and negative 5. So depending on this trend, we are going to write the general formula on that. So let's continue here. So with this we have so writing f of x when n is 0. So we have, for the first part, so look at, for the first part we have the ln of 3 plus 4x. That is when n is 0. So when n is 0, now remember we said at x is equal to 0. So when x is equal to 0, we have all of these being the ln of 3, right? That is when n is 0. So let's look at for the rest. Now for the rest we have for f to the power n, right? Then we have x over here, then it will be equal to, so we are going to write this general one in terms of when we differentiate with the first differential, second differential, third and fourth and the fifth. So let's look at the trend. Now for the first part, the first one was when n equal to 0, and we have this, the formula for that as this. Now we are going to look at when with the first differential, second, third, fourth and fifth. So we are going to use this trend to write the general formula out. So let's look at the first part. Now if you look at the first part, we have positive, we have negative, we have positive, negative, and positive. So how do we write it out? So we have so we realize that when n is so that's when, for this one, when n is 1, when n is 2, when n is 3. So realize that when n is for the trend it was positive, negative, positive. So we can write it as -1, right? -1. Then depending on the powers, we can write that it is n plus 1, because if for this one, when n is 1, for this part, when n is 1, we had positive. So when n is 1, then we have -1 to the power squared, then it is just positive. When n is 2, then we have 3. -1 cube is just negative. So we can see that when they are even numbers, we have positive; odd numbers, we have negative. So this formula over here to represent the negative, the alternating negative and positive, is going to work. Now let's move to the next one. Now for the next one, it has 4 4 4 4 throughout. So how do we write that formula? So we realize that it is when n is 1, when n is 2, when n is 3, when n is 4, when n is 5. So it's basically 4 then to the power n, 4 to the power n, just to represent that particular trend. Now the second trend is 3 plus 4x, 3 plus 4x, and look at the power. So 3 plus 4x to the power -1, 3 plus 4x. So we have also 3 plus 4x now to the power -1, -2, -3, -4, -5, then it goes on and on. So how can we represent that? So with that, we have it's just when this one was when n is 1, when n is 2. So you can see that it's just n throughout. So it is at -n, -n. So it is just -n, because when n is 1, we have -1, which is that. When n is 2, we have -2. When n is 3, when n is 4, and when n is 5. Okay, now the last one is where we have 2 3 4. We have 2 3, we have 2, and over here is just 1. So yeah, it's just 1. Then over here is just 0. But the trick here is that it is equal to the factorial, because we have if this is 0 factorial, 0 factorial is just 1. Then over here, if it is 1 factorial, it's just 1. Over here, when it is 2 factorial, it is just 1 multiplied by 2. 3 factorial is just 1 multiplied by 2 multiplied by 3. Then over here is just 2 is 4 factorial. So 4 factorial, that's 2 multiplied by 3 multiplied by 4, right? Okay, so we are going to write this in terms of factorial. So we have that trend to be 1 0 factorial, 1 factorial, 2 factorial, 3 factorial, and 4 factorial. So we have 0 1 2 and 3. We are going to find a formula for that, and we are going to use an arithmetic sequence over here, because if you have so let me quickly do it. You have an equal to a plus n minus 1, then multiplied by the common difference. Then an is basically, now the first term is 0, then multiplied by n. So we have n minus 1. Now the common difference is just the second term minus the first term. So 1 minus 0 is 1. 2 minus 1 is still 1. 3 minus 2 is 1. So you realize that it is factorial. So it's just 1 factorial. So over here we are going to get in all, an is just, this one goes away, and we have n minus 1, then we have factorial. So n minus 1 factorial represent this sequence over here. So we can add n minus 1 factorial. So basically this is all for the general term for when. So this is for when n is starting from 1 2 3 4 and 5. For the general term over here is when n is 0. So this is what we have. Now we can further simplify this. So we have f to the power that being equal to -1 n plus 1. All right, so we have -1 here, n plus 1, Then we have 4 here, n to the power 3 plus 4x negative 1, then n minus 1 factorial, representing this when n is starting from 1 2 3 4, not when n is 0. When n is 0, this is what we add. Okay, so with this we are saying that at s is equal to 0, then we can have f of n 0 here, then we have negative 1, n plus 1, then we have 4, then n over here. So when s is 0, it goes away, then we have this negative 1, so it is negative n, then we have negative 1 factorial over here. Then finally we can write negative 1 n plus 1 here, then this can be written as 4 over 3, then n here, because 4 to the power n, it is also to the power n, but it is negative, so we divide it, and we have n minus 1 factorial. So basically this is what we have. Now from here we are now going to write the general one. Now, and in general we have the value f of x being equal to, so to write the general equation, remember we had the general equation as this. So f of x will basically be the first term, the first sequence, which was this, and that this corresponds to the first one we add over here. So we add f of that, so we can have f of 0 here, right? So okay, so let's write it this way: the ln of 3 plus 4x, that is the general equation we are supposed to find, will be equal to the summation of so we are writing this over there, so it's equal to the summation f of n, then we have 0 here, so we are writing this according to the general one here. So we have x minus a, then as I said over here, s is equal to a, so a is 0. So when a is 0, we have x just to the power n, so we have x to the power n divided by n factorial. So this is the general one, and this is equal to the terms now. So now the first term we add over here when n is 0, because it's starting from when n is 0. So when n is 0, so we have n is 0 and n is then infinity. So when n is 0, then we can have our first term as f of that. Now the second term, we had a general formula for that, so we can write that as but this time it is when n is starting from 1. This one was n equal to 0, taking care of all of that, but when n is 1, then the general term is given by f of n, then 0 here, s to the power that, then divided by n factorial. So since we have this, it's equal to the ln of 4x here. Now from here we have the ln of 3 plus 4x here being equal to, so in general we can have this f of 0 as that here. So when x is equal to 0, so when x is equal to 0, we add that, so it is just ln 3, then the rest of the sequence was just that. So the whole of the sequence is representing that. So we have the summation of all of that. So we have negative 1, then n plus 1 multiplied by 4 over 3 to the power n minus 1 factorial divided by n factorial. So we are going to write the general one here for it to look nice. So we have the ln 3 plus 4x here being equal to ln 3 here plus the summation of now we have n factorial here, so let's group them at 4 over 3 to the power n. And let's do this over here. We have n minus 1 factorial over n factorial over here. Now note, just a note over here, when you have n minus 1 factorial divided by n factorial, it's just n minus 1. Now to expand this is just n minus 2, then you can go again n minus 3, so you can go on and still factorial, all divided by. Now expanding this also is just expanding n factorial is just n, so we have n minus 1, then it goes n minus 2, then it goes n minus 3, on and on, so that then it's still factorial. So factorial cancel factorial, n minus 3, n minus 2, n minus 1, then what you are left is just 1 over n. So I'm going to replace all of that with 1 over n. So we have the ln of 3 plus 4x here being equal to the ln 3 here plus the summation of -1. So starting from infinity n equal to 1. Remember, it's n equal to 1. This is just n equal to 0. So -1 multiplied by 4 over 3 factorial, then we have divided by n, because so all of this is just times 1 over n, which is okay. So just to add one last thing, we have s to the power n, so just multiplied by s to the power n, then multiplied by s to the power n, so we have x to the power n also here. So this is what we have. Okay, so thank you very much, and I'll see you in another section. Have a nice day.